Okay, welcome to the fourth part about FMI in industry. This time we will talk about FMI and give an introduction to it. Now let's directly dive into things. What is the motivation about this? We want to exchange simulation models. We have different tools on the market and they have all their individual goals and their individual aim that they look for. And what we often see is that if you take two simulation environments, they are incompatible. They have some proprietary storage solutions and stuff, so you cannot exchange models easily. So now what we would need is some wrapper around simulation models that would allow us to put simulation models from one simulation environment into another. So to exchange simulation models more or less. And as there is nothing yet created so far, there was an artificial file type introduced called FMU. And this is the files that the FMI standard defines, functional mockup unit. So just to get the nomenclature clear, FMI or functional mockup interface is the actual standard we are talking about. This is a text, you can read it and you can work with it. Functional mockup units, in contrast, are single simulation models. So you have a single file that's a simulation model, and this is called an FMU, if it's according to FMI for sure. The simulation environment is the software, for example, your simulation software that you use in order to run or create FMUs. Typically, you run them. Creating is another thing. This is more like export. And we will talk about dynamic linked libraries or shared objects, also known as DLL, maybe more common. SO is also common, but DLL is more in the Windows world, or is in the Windows world, while shared objects is in the Linux and Mac world. But it's in fact the same thing. You have libraries provided typically by the operating system that share some code or some functions to programs to be executed. So FMI is currently in version 3. There are versions 1 and 2 available. Each major version, 1, 2, 3, was a significant improvement to the previous one. And what we currently see is that in industry we have more or less 2 and 3 present. 3 is rather new, while 2 is, I would say stable enough to be in industry actually used. 3 is going to come soon, but not yet. When we talk about FMUs, there are different kinds and different types of FMUs available. And these are model exchange, co-simulation, and scheduled execution. And they have some difference that they classify. And while most model exchange and co-simulation was always there, scheduled execution was introduced with FMI 3. And the difference between most model exchange, co-simulation, and scheduled execution is how they are intended to be used. Model exchange is more or less only the right-hand side of a differential equation or difference equation, depending on how you define it. And the simulation environment itself is responsible to provide numerical integrators. On the co-simulation, you have a more contained system. As the name suggests, it's about co-simulation. And in fact, if you had some differential equations inside such a co-simulation FMU, then you as FMU provider would have to provide the integrator function as well. So the simulator is included in this co-simulation, and all that the simulation environment can do is just say, oh, please go whatever 2 seconds into the future, and then your FMU as the FMU or as the provider of the FMU have to provide some feature or some function, some implementation to calculate the state in 1 second or whatever time the simulation environment requests from you. And scheduled execution is some sort of niche. It was introduced but never really implemented. So this is more or less about clocks and how to react on certain things. It's more in the event-based mode. But as there is not really any software out there using scheduled execution yet, we'll see where this will get. Practically, we have co-simulation used in 90 or 95% of all cases. It's co-simulation. Model exchange is only for scientific use cases. In industry, we use co-simulation. Inside such an FMU, we need some implementation. We need to implement whatever is there, like the right-hand side of a differential equation or the difference equation involved with co-simulation. Doesn't matter. There are 2 kinds how this can be done. This can be done in binary form, so you have some libraries, DLL, shared object, you remember. But you could also provide source codes like C files and stuff, and provide some recipe how to compile them. The simulation environment is then responsible to create such a DLL or shared object or whatever is required on the architecture we are talking about to run that FMU. So in the end effect, you will run a DLL shared object or something similar, but it depends how this will be stored within the file. And also combinations are possible. So it can happen that, for example, the FMU provider decided, okay, I put the sources there, but for the most common use case of maybe because all of my customers are using Windows, I put the Windows DLL files there as well, just as an example. Then this would be perfectly fine, and the simulation environment will take whatever it suits best. However, there's one point we have to think about, and this is opacity. If you have binary models, then you have a black box model. You cannot look, just by looking at the FMU, what this simulation environment, a simulation model will do actually. So you can somehow prevent outsiders from looking at your implementation. While if you are providing the source code, it's rather easy to understand what you put in your FMU. So there is a small distinction between those 2. And again, in industry, in most use cases, you have binary FMUs because you don't want to mess around with compiling in reality. But this option is there, and it's generally working. From a simulator's view, this is also a recap more or less, we have some things that we expect from a simulation model. We have the state, the input, and eventually some output or some measurement. Why? This is the general things that we already mentioned in part 2 about simulation and simulation models. Now, what does this mean for FMU? If you have a model exchange FMU, then we need some method, some function that will get the right hand side of an ordinary differential equation that the FMU represents, given the state, the input, and time eventually. And then we have the co-simulation, where we have actually the question, okay, I'm here at some point, I already mentioned that earlier, just give me the state at a certain point in time in the future. So I request the FMU to integrate itself to a certain point. Something that comes with FMI 3 is the zero crossing detection, more or less. So you can add structural changes and handle events depending on your integration result. With FMI 2 there was already some support for this. With FMI 3 there was an improvement on this side. In general, it's possible to switch to so-called event handling mode, and then you can do discrete event handling without integrating in time, just stopping the time and doing your events, and then you can restart the continuous time more or less. But this is depending on your use case either very important, or you don't do about this much because it's not working for you. So what do we need from a model? And here we look at the co-simulation as the most prominent one. We need to get or set the value of the state. So we need functions, not mathematical functions, but library functions that allow us to set and to get value of this state X. We also need to set somehow the input value U, and we might need to get the output value Y. In fact, the FMU allows us to even get the inputs and set the outputs. This is more about an advanced feature of FMI. It's not a bug, it's a feature. Yeah, I know. This is if you want to do something like Euler's approach, where you solve for roots for zeros, and there you might need to do some more fancy stuff. But back to co-simulation, you have these very basic functions that are shown here. You need something to advance the time to the next communication point, and you need something to handle the event structural changes, because all these things from the outside looking at the FMU, you have no way to make the FMU do as you like. You have to provide functions in the API of your FMU that allow you to do exactly those things. And this is more or less the topic or the task of functional mockup interface, to define such an interface such that it's working as expected. And there are some implementations of FMI. For example, I'll show you two. One is FMPy, which is a Python implementation. You can think of it as it's provided by one person in the FMI consortia, and it's used mainly for debugging and testing, and it's not a real simulation environment. It's more like reference implementation, if you want to call it like this. But you can actually build your own integrators and your own simulation environments with it. It's open source, you can do it what you like, and there is also the link that's rather easy to type. Then there's Daimola. Daimola is the proprietary big simulation environment that is based on Modelica. It's for arbitrary complex models, it's multi-domain and blah blah blah. I think it's the most used Modelica implementation in the world, and supports for sure import and export of FMUs at arbitrary levels. But of course it's paid and proprietary, so depending on what you want to do, this is not your best solution. But there are a ton more tools depending on which FMI version you are talking about. In FMI 2 it's I think 250 tools or whatever in the world, and getting more day by day. And these tools don't share all their features and all their main goal, but they address different aspects. And there is also a compatibility matrix that you want to have a look at if you are really interested in certain features, because then you can understand what these tools can do or cannot do. Okay, this was the introduction into FMI. This was a rather high-level view how things are working. Our next video will be about a more in-depth view of FMI and how an FMU is actually built, and then we get into the implementation stuff. I hope we will see us soon and you continue looking at the videos, and see you next time.